It's amazing what the paper can take, right? So thank you for that introduction. I appreciate it. I'm going to have my stand here next to the podium so you can see me, and then take the opportunity today to dive a little bit into these admixtures for LC3 Cement, which is a title that I didn't pick. Somebody picked it for me. I'm not going to say who, but I'll do the best that I can, okay? So let's get this going. First things first, where is my next page? Page down? Is it going or not? That does it. So this is a little bit of a twist. I don't know that you were expecting this on an LC3 presentation, but as industry leaders, I think, and I will ask that everybody takes the opportunity to lead with safety in everything that you do. That's what makes sure that we go out of the house in the morning and come back at night, and not only for us, but our families. I think if I look around, everybody has maybe a grandchild or a niece or a child or someone. I want to make sure that when we take the opportunity to go back home, we pay attention to the fact that there are these kind of labels in a lot of the furniture in our properties. And you do that because in the United States, this is a statistic in the US, every 17 minutes, somebody is injured by a furniture or a tip-over type of accident. And so if we can avoid it, please, let's be sure we keep our family safe. And when you buy furniture, make sure that, there is an ASTM for that. I know we look at ASTM for testing slump and air and whatnot. There are ASTM standards specifically to test furniture tip-overs. Be on the look for it, and we'll be a little safer. With that, I will say that the observations that you'll hear are mine. Nobody forced me to say that, but I want to say it to make sure that if I make a boo-boo, that everybody understands we can always work it out. This is intended for educational purposes, and so all of the opinions are mine. First of all, and I want to recognize Larry Sutter, who has been in this convention and elsewhere talking about a word that I think I caught maybe in both presentations, for sure in Andreas, is the word alternative. Now the word alternative is like the sustainability of the new generation. Everything is an alternative. But I pause here to say that indeed we start out with the concept of the existing players in our industry, in the concrete industry. Right? So we got the Portland cement that we've used for hundreds of years, and the traditional materials. But are they really traditional? Because if you look at the second bullet, I have coal ash listed. Why didn't I put fly ash? Well, I didn't because even the fly ash that you get today is not the same fly ash that you used to get. Now, all of a sudden, you are allowed to have bottom ash ground as part of your fly ash. You are allowed to have harvested ash, which, by the way, the word harvested was peculiarly picked so that it didn't have legal ramifications when you talk about recycling, or some of the other terms are tied to issues that would get in the way of progress. So those words are specifically picked for that. So harvested ash all of a sudden can be part of coal ash going into concrete. Slag cement, natural pozzolans, and silica fumes, the usual suspects as the existing players. Larry's saying that you've always used the supporting cast, right? Aggregates play a big role in concrete performance as much as admixtures. But here we come to the new players, and that's where the alternatives come in. Now it's alternative cementitious, alternative cement materials, new binders, and therefore the new supporting cast is new admixtures. Everything that we have heard thus far with ordinary Portland cement and even the type 1L that Andreas was talking about, it's almost like reset button time, because new admixtures are going to be needed for those alternatives and new materials that we're talking about. And many times you'll hear that, oh, we're not ready for it because the specifications don't allow it. I can submit to you that there's significant activity in the specification space. I copied and pasted a bunch of ASTM top headings on the right-hand side of the screen. And when you look at the dash number, it's tiny small, but you'll see dash 24, dash 23. This is the year of the last revision of those standards. And just as I mentioned that the fly ash is no longer fly ash, but it's coal ash in the spec, the same is happening across the board. The same 595 standard that you might have used in the past is not the same as it used to be. So a lot of it means you can do more than you thought you could. All you need to do is go back and reference some of those standards. And when you do that, you'll see that the LC3 cements that we're going to talk about today, technically speaking, there's no impediment for them to be manufactured. The trick is going to be the pairing with the market and when the technology actually is scaled up to perform. I have listed here also, courtesy of Larry, a bunch of updates in terms of what's ahead, a lot of activities in progress. So we will be able to have those alternatives that I talked about much more up close and personal in our regions. There may be more advances in one geography in North America, but it's going to be throughout our industry overall. So I'm talking background about the LC3 cement, right? And I'm saying all this is new, or sounds new. But then I have to recognize Karen Scribner, who was here in the convention. If you haven't met her, she comes here every once in a while. She actually, 17 plus years ago, said the following: this material, and I'm going to ask you what the material is. This material has the potential to cut CO2 emissions related to the cement by more than 400 million tons a year at a global scale. What material is that? Calcine. Okay, so I'm done with my presentation, right? So, thank you. We can all leave early. Absolutely, calcine clay, but I don't know if everybody is aware of that, so I decided to just make a whole slide for it. Why LC3? And I think it should be obvious. If somebody can see it, you know, there's an L in limestone, there's a C in calcine, there's a C in clay, and there's a C in clinker, so LC3. They actually put it with a 3 usually is an exponential figure. But so LC3 plays a role in this, and that's, again, the cement that we're going to concentrate. That being said, I have to say, this is one lever that the industry is pulling to achieve lower carbon intensity in concrete. It's one of them. Doesn't mean it's the only one, but it's one of them. And when you look at the alternatives that I was talking about earlier, you know, these are the new SCMs, or all materials but are being used now differently. You can see a whole series of options out there that are going to be entering the market because of those standard updates that I just mentioned. And just before you check on me, where is a mistake in this slide in the photos? Let's concentrate. There's a mistake. I found it. I didn't do the slide, but I'm going to own it. There's a mistake in the slide. Where is it? Look at the pictures. Yes, yes, you saw it right there. That is not it. GGBS is really what would be the equivalent of slag cement, so it's a powder, not a mountain of pebbles. But that being said, the point being taken here is that we have all kinds of ingredients making it into concrete. Calcine clay is one of the answers, but it's not the only one. Now, why we need this? Because LC3 has got one edge over a lot of these other things. Everybody's talking about how much slag cement we're going to have in the future in terms of volume. Is it going to be available in all the markets? With coal ash or fly ash as listed here, many people are saying, well, now we got to harvest because there's not enough fresh ash generation. And how long is that going to go? And so there's a question as to how can we scale, you know, to the billions of tons of cement that get made in planet Earth with, you know, resources that are actually disappearing. And that's where natural pozzolan and other materials such as the clays and that famous calcine clay that you said become important. Because there's, just like limestone all over the crust, there's a lot of clay all over the crust. And so now we have the opportunity to not be a niche type of offering. You know, there are new binders, as they reference them when we talk about alkali activated binders and so forth. Well, yes, perfect. There's unique applications. You're going to have those where they belong, but can you scale to billions of tons? And so the question is, how can we do that in the most practical fashion? And that's what gave birth to the calcine clay concept. At this point, there is probably more than 40 now, but 40 cement producers in about 25 countries working on LC3. So that's an up-and-coming attraction. Just like LC3 surfaced and appeared in many markets very fast, it'll be probably another 2-3 years maybe that we're going to start seeing the entry of these kinds of materials, at least in the United States. It is already present, for example, in Colombia. I know we've worked on that there. And so Europe as well. So other parts of the world are already seeing it. But I'm just talking specifically US, maybe a couple of years away, given that there's some investment devoted to prepare industry to have calciners on site to prepare the LC3 formulation. So an up-and-coming attraction there. And the why behind it has to do with just pure math. If you already have clays all over the world and you already have limestone all over the world, you can still have clinker. And now with material like a calcine clay all over the world near cement plants, you can actually have as much powder as you need. If you compare those two boxes over there, clinker, calcination temperature 1450 C plus minus, overall round figures, you're going to look at about 800 kilos of equivalent CO2 per ton. Now, the calcined clay is not zero, and many of us are used to saying, yeah, I'm going to put ash in my concrete so that every ton of cement I get out is a ton of savings of CO2. It's not a binary 1-0 situation here. Calcined clay does produce, but because the calcination is at a much lower temperature and so forth, the process can actually save a significant amount of CO2. So even though you're still going to be making CO2, you need other levers for the net zero approach. This one actually helps tremendously to get sort of the binder part of it to cut in terms of emissions attributable to the material itself. And the formulation, if you will, just compared to what we have of ordinary Portland cement, which tends to be just clinker with a little bit of gypsum, and that gives you the ordinary Portland cement concept. The formulation would be proportioned as such. About half would be the remaining clinker that you used to know as Portland cement clinker, but you would also have then 30% of that volume to be the calcined clay. And then you would add about 15% limestone, which is where the industry is right now, with your gypsum. This is probably not final in terms of what will be unique in your market, but directionally speaking, this is a formulation from, the LC3 concept. So as background, I wanted to offer this as a starting point. And now we get to actually replace some of the clinker with the calcined clay. Yes, I have a picture of a fancy instrument because, yes, a lot of the testing that we talked about earlier, I think Georgia Tech is really doing, they put a picture of all the instruments that they're using to characterize materials in the lab. You're going to need access to, good friends, collaborators, maybe alliances with organizations, companies, what have you, to help you navigate the waters, because you will have to do some work in order to get to characterize these materials in a way that you can actually address the performance needs. One way to address performance is the way we do it is, you start looking almost like a spider web, and this is representative. It's not, the only one. Other people can do it differently. But you're going to look at, the opportunity where the variety of clays are going to give you different performance. This blue line is one particular calcined clay. This orange is another calcined clay. Which one are you going to get? You're going to have to do the work to find out. And work with your suppliers, work with your consultants, work with your team, your experts to get to do that. Those charts on the right-hand side are basically a summary of different calcined clays that we have actually investigated in our facilities, among others, because we've done across the globe. But each one is a different calcined clay. Which one is for you, again? You are going to have to understand, for example, in the colors in the bar, it's like how much is quartz, how much is kaolinite. And that word, you will remember me. When you look at LC3 and you look at calcined clay in the future, kaolinite is going to be one factor that you're going to pay attention. So if you remember one thing from today, is you're going to be looking at that. Just like today, you say, well, I want to know about what is my C3S. Everybody wants to do that in the traditional ordinary Portland cement. You want to keep an eye on that, and that's going to be one of the conclusions. So I'm telling you what I'm going to tell you, I'm going to tell you, and then I tell you what I told you, right? So remember that one, because overall is going to be important for you to keep an eye on that. You see the diversity and the variances in terms of what's in the calcined clay, and you will see the impact when it comes to water demand. It could be double one from the other. And we are used to using chemical admixtures in order to deal with water demand. So what product is the one that you're going to need other than water to control that is going to be important. Particle size distribution also varies widely. So you can imagine that in order to tune your performance, you're really going to have a good handle on it. So in a way, I'm saying, let's fasten our seatbelts. It's going to be a fun ride ahead. If we do it in anticipation of what's ahead, then we can put our arms around it. In other words, there's work that we should start doing now so that when this comes about in 2 years, we basically have connected the dots in a way that's efficient. Very simple, and I'm glad that Andreas and others touched on these properties, so you already are experts. This is actually yield stress, so the higher the number, the more difficult to move that material. The black line is what you would have, and this is representative, in terms of zero time to 120 minutes. You can see that it's a high number, so it's high yield stress to make that move. That means it's tough to move if you start with nothing. And then if you use, some workability with admixture, you see that now it's easy to move early on, but as time goes on, it gets more and more difficult to move, right? So that's not desirable, but a traditional admixture probably is going to give you the red line. What we're saying here today is that by doing the work that I said, that spider web, and characterization and alliances with your partners, you will be able to come up with what the chemistry needs to be so you get the green line, which is basically the holding of the slump, as we call it, and as Andrea mentioned, from the job site to the field. So it's going to be important to work together on getting that answer. And the reason is, otherwise you're going to have the dash line, which is conventional admixtures. You put it in, it's going to give you the work at the beginning, but over time it's not going to work. And the idea is to raise, as the solid arrows point out, is how do you get those up with the particular materials in your area? Same is going to happen with strength. The good news is that it's achievable. Okay, you're not going to have to necessarily give up the opportunity to get strength. You have a control here in the gray line, and you have at 7 and 28 days. At other ages are different strengths, but what you can see is that you can have an LC3, but picking the right product allows you to basically match and pair performance to what you're used to. Usually, I don't know how, I'm going to date myself, but there was a commercial from Burger King a long time ago that says you cannot have, or you can have it your way. Well, sometimes you cannot have it your way. You may have to trade off if you really want to be, for example, looking at early strength. You may want to pick C admixture with your LC3, and then that means you're all the way to the right, but you're going to have it your way. You don't have the 28-day. Or vice versa. You may be more looking at later age, or you could find a balance, which I strike as A. That may be the happy medium. You give up a little bit here, you give up a little bit there, and you're able to get the performance that you aspire. So this is what we have done, but you have the power in your hands, thanks to Karen again. She actually published this paper back in 2019, and it's a very detailed paper in terms of what you can do to do that assessment yourself with your resources and with the people that you may find can help you with that. It's actually, I'm going to make it easy for you, so you don't have to read it. You just get this slide. Key items. But the first word that I have up there is the one I told you need to remember, because the kaolin content plays a major role in the rheological properties as well as the strength development. So this is going to be your, remember we talk about C3S with we're experts with clinker, right? Well, with calcined clays, you're going to have to look at the kaolinite content. Now, I also have here another of your best friends. You may not have access to thermogravimetric analysis. Find a friend, phone a friend, or as they say, because it's going to help you to be able to characterize these materials in the future. And this test, the R3 pozzolanic test, there's an ASTM for that. This shows you what I'm trying to, I have been saying it, but I'm going to say it now clearly. When I said collaborate with your alliances and partners to get things done, this is an example of how RILEM, for example, in Europe, did a bunch of testing, but they were taking forever to come up with development of a test method that was standardized. So RILEM, through Karen, shared the data to an ASTM committee. Then they got the ASTM standard developed, and now they can reference it in Europe. So this is a way of bridging the Atlantic. We need to bridge the world with collaboration. Collaboration is going to be the name of the game to be successful. If we try to do it alone, you can, wish you luck. The idea, again, is collaboration to get these things. This test, if you're not familiar with it, is relatively recent, but it's been used in research quite a bit. I suspect it's going to be more common in the field going forward. And it's going to be also necessary, as I said before, each calcined clay is going to be its own DNA, because even the processing can impact. I mean, you can make up for anything, but the process is going to be unique. You can have the same material processed differently, different performance. So looking at that, the good news is that we actually have already characterized as an industry the reactions, and there is very slight variation just from plain cement hydration products, so we're good there. And just to prove you that I'm going to remind you of the importance of kaolinite, I repeated that bullet. So if you took a picture of the previous slide and you didn't get it now. The kaolinite is going to be very important. And here's the trick, about 40% is actually necessary for the LC3 formulation as I described it, in terms of the 50%, 30%, 15%, 5%, to give you the equivalent performance adequately treated with admixtures, to give you the performance, again, in terms of workability, strength, and what have you. And it also, too much of a good thing can be a bad thing, right? So I highlight that clays with 40 to 50% current are probably better than pure clays in terms of what will be for workability. And then there's a lot about carbonation in this day and age. There's just a bit a delta there in terms of carbonation. We might want to consider that in the future. But at this point, I'm going to just sum it up to simply, high bullet items. The use of calcined clays is one of the levers to reduce CO2 in concrete. There is a broad range of clays globally, but that's the good news, is that we can scale up and have millions and millions of tons of this product and not necessarily suffer the fact that it may be here this month and 6 months from now I don't have a delivery. They incorporate the calcined clays, and the calcine is important to basically control the performance. And there is proprietary, as I show you, our spider web, but then there's the paper from Karen that can give you that ID for that clay so that you can address the performance and get it to do what you need. Bottom line is, it's going to be, glove in hand, development, so that what you have and what you need gets to work for you and may not work for somebody else. So with that, I just wanted to say thank you for your attention. And if there are any questions or anything like that, Tunam is here and Andreas is here. And but no, I'll do the best that I can.
Thank you.